All right, 5.7, day 1. Okay, so like I was saying, today's lesson is basically giving you guys something that will make yesterday's lesson easier. Because with the homework, you guys probably saw that, you had to do a lot of guessing and checking, right? And then you just kind of guessed and checked until you hit that remainder of 0. And you're like, yay. So this gives you a better strategy, or it gives you insight so that you don't have to just blindly guess and check. You still have to guess and check, but this will give you a little more of a hint on what to guess and check. Okay? All right, so the first part here, I actually told you guys this, I guess last lesson, little spoiler alert, I actually gave this one away already. This is basically saying that the degree of your polynomial is how many roots you should expect. And I think I told you guys that yesterday, right? Like if you have a degree 3 polynomial, you should have 3 zeros. If you have degree 4, you should have 4 zeros. All right, so that's that first part. The second one, this is what we're going to focus on today. Does anybody know how to pronounce this guy's name? Anybody want to try? I think it's French, if that helps. Joseph, give it a shot.
All right. I'm not too sure what I'm looking at right now.
So the thing that I underlined, it starts with a D.
Degree.
How would you pronounce that?
Oh. Descartes.
I'm so glad I called on you. Pretty good. Pretty good. It's French, so try with a French accent.
It's
okay. Don't worry about it.
Right. Leong, can I try?
Yeah, go for it.
It should be Descartes.
Zoe. Oh my goodness. Yes. French. Very good. Descartes. Yeah. So it is not Descartes. Okay. It's Descartes. Descartes. So perfect, Zoe. Nicely done. So this is Descartes' rule of signs. All right. I'm going to read it to you. It's not going to make a lot of sense, but then hopefully after I show examples, you can go back and it'll make more sense. Okay. So let me read it to you. If p of x is a polynomial with real coefficients whose terms are arranged in descending powers, all right, so exponents goes from the highest to the lowest, the number of positive real zeros, right, the number of positive real zeros is the same as the number of changes in signs of the coefficient of the terms, or less than this by an even number. Okay, let's break that down. Okay, so let me show an example of how we can use this. Okay, so number 1, first off, check to see if it's arranged in descending powers. So here I have x squared plus 4x minus 21. Yes, descending powers, perfect. Then it says it's the same as the number of changes in sign of the coefficient of the terms. All right, so that means we don't really care about the number. We are just caring about positives or negatives. So looking at number 1, this is positive, this is positive, this is negative. So how many changes in signs do you guys see? One. Yeah. All right, there's only one change in sign going from this positive to this negative. All right, so that is a change in sign. So that means the number of positive real zeros, all right, so number of positive real zeros is 1. Or less than this by an even number. Well, if I did less than that by an even number, it's like subtracting 2 basically, I would get -1. Okay, so that doesn't make sense. I can't have -1 number of positive real zeros. So that just means I have exactly 1 positive real zero. All right, so that's what Descartes' rule of sign, that first part, tells me. All right, let's try this next part. The number of negative real zeros is the same as the number of changes in sign, again, of coefficient of the terms of p of -x or less than this by an even number. Okay, so it's like the exact same thing, but instead I need to find p of -x. Okay, so if I do p of -x, let me erase this, sorry. Oh, I can't erase it, never mind. Let me go ahead and plug in -x. So this is -x² for this first term, plus 4 times -x for the second term, minus 21. That gets me negative, oh, sorry, that's gonna be positive, right? Because the square, minus 4x minus 21. Okay, so looking at the sign changes, I'll just put it underneath here. I have positive, I have a negative, and I have a negative. So what I notice is how many sign changes? Well, I have a sign change from here to here. A positive goes to a negative. Negative to a negative, it didn't change sign. So I have 1 sign change. So that tells me in terms of negative, right, the number of negative real zeros is also just 1. And that's it. I have 1 positive real zero and I have 1 negative real zero. Okay, or I guess it says state the number and type of roots. Roots are zeros, by the way, in case you guys didn't catch that yet. Roots are the same thing as zeros. Okay, so I have 1 positive real and I have 1 negative real root. Okay. And if you don't believe me, all right, you can even test it out. If we were to solve this, let's see what happens. I factor and I get x plus 7 times x minus 3, and I get x is equal to -7 and 3. So hey, it's true. I got 1 positive and I had 1 negative. So the Descartes' rule, it worked. It worked. Okay, let me show you another one. Let's do number 3, actually. Let's jump to number 3. All right, so number 3, I'm going to do the same thing. I'm going to look at the number of sign changes. Okay, so the first one, I see positive. Notice I'm missing a term, but 0 is considered neutral. So it's okay. You don't have to do like a filler, a 0 term for that x². You don't have to do that. Okay, so don't worry about that because 0 is kind of a neutral. And then I have a positive. All right, so I have a positive and a positive. So what this tells me is that in terms of the number of positive real zeros, I have none because I have no sign change here, right? There's no sign change. All right, so let's try it with the negative. So if I have, when I plug in negative here, I'll just do it above, x, and I have a negative x. Here's a little shortcut. You guys don't really even have to simplify because all we care about is if it's positive or negative. So if I look at this one, well, negative x³ is still going to stay negative. And then 100 times negative x, well, that's going to be negative also. So for this one, p of negative x, I have no sign changes as well. So that tells me in terms of negative real roots, I also have none. So I have no positives, I have no negatives. That means they're all imaginary. They're all imaginary. So let me prove it to you. If I were to actually solve it, let's see if this is true. I would factor, let's factor out the 2. All right, and then I would, I could have factored out a 4, my bad. Let me factor out another 2. Here I would get x is 0. Here I would get 3x squared plus 25 is equal to 0. And if I square root, I get x is equal to plus or minus, this is 5i over rad 3, which gets me plus or minus 5i rad 3 over 3 when I simplify. All right, clean that 3 up a little bit. All right, so yeah, you can see I have no positive, no negative. 0 is considered neutral. So I have 0, I have 1 real root, and then I have 2 imaginary ones. So I have no positives, no negative. So I have 1 real, and then I have 2 imaginary. All right. Okay. So that's kind of how Descartes, so I'm just trying to prove to you guys that Descartes works, right, with those 2 examples. It's not a proof, but it's just to show you that it actually does work. So let me go ahead and show you with a more kind of complex example. All right, so flip to the back. And again, imagine using this with like the problems you did yesterday for homework. Knowing how many positives and negatives there could have been really helpful, right? Because if you know, I have, 1 positive, right? And I have 2 negatives. Well, then it's like, oh, well, let me try the negatives because I know there's at least 2 negatives. So you might, try the negatives in your synthetic division. All right, so number 5, state a possible number of positive real zeros, negative real zeros, and imaginary zeros for each function. All right, so they just want to know how many positive, negative, imaginaries. They don't actually ask us to solve. Okay, so let's use Descartes' rule for this one. So first, let's look at the sign changes. All right, it goes from highest degree to lowest degree, so that's checked out. I have a positive, I have a positive, I have a negative, and a negative. Okay, so I see I have 1 sign change right there. Okay, so this tells me that I have 1 positive. Okay, let's try it with the f of negative x. So f of negative x, right? Imagine plugging in negative x into these x's. And you don't really have to show work for this, right? When you plug in negative x, that cube would stay negative. This square would be positive. Plug in negative x here would be negative 8 times negative x, so that's positive. And this negative 12 is still negative. All right, so this, I can see I have 1 sign change here, doesn't change here, but it does change again here. All right, so this time I could potentially have 2 negatives or 0. Now, the reason why I say or 0 is because if you look back at Descartes' rule, it says the number of sign changes or less than this by an even number. Okay? So if you get 2 sign changes, right, and you decrease that by an even number, that means you can have 2 or 0. Let's say you had 3 sign changes, then it can be 3 or 1. Let's say you got 4 sign changes. It could be 4 or 2 or 0. Let's say you got 5 sign changes. It could be 5 or 3 or 1. 6 sign changes. It could be 6 or 4 or 2 or 0. Okay, so you're basically always decreasing by 2 until you have to stop because it would go negative if you kept going. All right. So that's what it means, or less than that by an even number. Okay. So going back to this problem. So stating the possible number of positives, negatives, and imaginary, I think it's easiest to build a chart to kind of organize this. So let's go ahead and do that. So this will be the number of positives. This will be the number of negatives. And this will be however many imaginaries. All right, and let's go ahead and see what could happen. So for positives, I definitely could have 1. And for negatives, I could have 2, right? Or maybe I have 1 positive and then the 0 negatives, right? It could be either of those situations, right? Either 2 or 0 negatives, but it's still always 1 positive. Okay, now how many imaginaries? How do I tell that? Well, I know that looking at the degree, I should have a total of 3 zeros total. Well, if I have, looking at this first row, 1 positive and 2 negatives already, and I want a total of 3, that means I should have no imaginaries left. But in this case, if I have 1 positive and 0 negatives, I must have 2 imaginaries to get a total of 3. All right. And I'm okay with you guys just leaving your answer in a chart like this. So this is your final answer. All right. So basically this means I can have 1 positive, 2 negatives, no imaginary, or I can have 1 positive, 0 negatives, and 2 imaginary. And that's it. Okay, let me pause. That was a lot of information. So questions. Let me open this up. Okay, number 6. Let's try this one. All right, help me out with this one, starting with Ethan. All right, Ethan, what do we do first?
Do we find how many times the sign changes?
Yeah, go for it. What do you see? The first term, positive or negative?
Positive.
Keep going.
And then negative. And then negative again. And then positive. And then negative.
Yeah, so how many sign changes do you see?
4. Maybe I counted that wrong. 2, I mean. 1.
So I got 1 here.
Uh-huh. And then,
The next one a sign change?
so 3, right?
Good. 3.
Okay, yeah.
All right. We got change, no change, change, change. Okay. So Ethan, how many positive zeros could there be then? 3
2.
or wait, what?
Is it 2?
Oh, I thought you said
Sorry, what?
3 sign changes.
Oh, yeah, so then 3.
Okay. So 3 or
Or 0.
two.
I can't really hear you. Your microphone is,
Hello?
it's super quiet. Hold on. Let me try and mess with my sound settings. 1 sec. 1.
3 or 1. If I subtract by another 2, what happens, Ethan?
It's -1.
Can I get negative number of 0?
No.
No, so what should I do? I should just?
Put a 0?
No.
Oh, okay.
Not that 1. 3 or
Got
1.
it.
Always subtract by 2. Always subtract by 2. All right. The number of sign changes, -2 until you get negatives, and then you stop. Okay? But don't get
Okay.
Okay. All right. Let's try the next one. Angie, help me out with this. I want to find out how many negatives. How do I do that? How many negatives? Angie.
I'm kind of confused on this part.
Okay, so what you want to do is you want to plug in -x into our function. Okay, so when I plug in -x into this one, like this, is that going to come out to be positive or negative?
Negative.
Good. All right, try it with this one. When I plug in -x, is that going to be positive or negative?
Positive.
Well, -x to the 4th would be positive, but don't forget you have this negative right here. So that's actually going to come out
Negative.
negative. Good. All right. Try it again. Plug in -x into this one. What is that going to come out to be?
Positive.
Good. All right. Do the same thing for this one. Plug in -x. And does that come out positive or negative?
Positive.
Good. All right. And the last one, there's no x. So that's just going to be
Negative.
perfect. All right, Angie. So now just count how many sign changes. So if I go from the first one, negative to negative, is that a sign change?
No.
No. All right. What about the next one?
Yes.
Good. What about the next one?
No.
What about the next
Yes.
one? Good. So how many sign changes did we see?
2.
Always subtract this by 2 until you hit 1 or 0. So this can be 2 or
0.
perfect. Good job, Angie. Nice. You got it. Okay. So that means I can have 2 or 0 negative roots. Okay. Nice. Let's continue. Rachel, help me out with this next part. I'm going to build my chart. Okay. So Rachel.
I'm also kind of confused with this part.
Okay, that's okay. Help me out. So I have positives, I have negatives, I have imaginary. Okay, so Rachel, what's one possibility of how many positive roots we have?
3.
Okay, so 3. What's one possible number of negative numbers we have?
1.
Oh, negatives.
Oh, 2.
Yeah, okay, so 2. So let's do that. Okay, so let's say we have 3, and then this 2. Now, how many imaginaries then should I have? Because if you look at the exponent, Rachel, what's the exponent?
5.
Highest exponent, sorry. In the polynomial, what's the highest exponent?
5.
5. So this tells me I should have 5 total every single time. So if I have 3 positives and 2 negatives, how many imaginaries then should I have?
I'm confused.
If I have 5, if I need to have exactly 5 total zeros, I have 3 positives already. I have 2 negatives. So how many imaginaries must I have to equal to a total of 5?
Oh, 4.
Well, if I have 4, how many total do I have? 3 plus 2 plus 4 gets me.
Oh, because I thought it was negative, so like.
So I
So
can't.
it would just be 0.
Yeah, there you go. So this gives me a total of 5, right? Okay, let's try another combo.
Mhm.
So pick another number for like positive. So let's say I stick to 3, but instead of 2 negatives, let's say I have 0 negatives. How many imaginaries must I have?
2.
2. Good.
2.
All right. Nice. So we're done with the 3s. Okay. I have 1 positive and the 2 negatives. How many imaginaries must I have?
2.
Good. All right. And what if I have the 1 positive and 0 negatives? How many imaginaries must I have?
4.
Perfect. And that's it. That is your final solution. So those are the possibilities. Does that make more sense, Rachel?
Yeah.
Yeah? All right. Good. Okay. So that helps us kind of see, all right, as I'm finding zeros, I should expect I can have 3 positives, 2 negatives, and 0 imaginary. Or maybe I have 3 positives and 2 imaginaries. Or maybe I have 1 positive, 2 negative, 2 imaginaries. Or maybe I have 1 positive, 0 negatives, and 4 imaginaries. So these are just the 4 possibilities of what might actually happen. All right, so this helps us kind of narrow it down when we're guessing and checking. Okay. All right. Let's have you guys practice with a little bit more. All right, let's go to number 7, and then I'll have you guys try number 8 on your own. Okay, number 7, let's go to Sebastian. Help me out with this one. You want to determine the signs. All right, so Sebastian, the first term, is that positive or negative?
Positive,
Good. Is the second term positive or negative?
negative,
Is the next term positive or negative?
negative,
Is the next
and positive.
Okay. Now, look at how many sign changes there are. Going from here to here, is that a sign change?
There's 2 sign changes in total. That's one change, and then there's another
Good. So how many sign changes total?
2.
Okay, which means that there can be 2 or
less.
so always subtract by 2. So 2 or what's 2 minus 2? What's 2 minus 2?
4.
What's 2 minus?
Those 0, 0, 0.
So 2 or 0, positive. Okay. All right, now Sebastian, to get the negative, what do I need to do?
And negative.
To get how many negative real zeros?
The amount of sign changes when you make when you make f minus x and stuff, f of x.
So you want to substitute, instead of x, you want to put negative x. So when I plug in negative x into this first term, does that come out positive or negative?
I think it comes out positive.
Good. What about the second term?
Positive.
Good. What about the next term?
Negative.
Good. What about the next term?
Negative, and it's just one change.
Good. So it can be 1. And if I subtract 1 by 2, I get negatives. So I'm going to stop at just 1.
So it's just one positive.
You mean 1 negative?
Oh, okay. Oh yeah, one negative.
Okay.
Sorry.
So Sebastian, if I make my chart, let's go through them. All right. So how many positives might I have?
2 or 0.
Okay. And how many negatives must I have?
1.
Good. How many zeros should I expect in total?
Uh, 3.
Look at your exponent, highest exponent.
Oh, 4.
4. So I should expect 4 total. So if I have 2 positive, 1 negative, how many imaginaries must I have to get a total of 4?
1.
Good. All right. Now I could also have how many positives?
How many positives?
Yeah. It could be 2 or
0.
0. Okay.
In
So
which,
I have 0.
in which case we need 3 imaginaries.
Perfect. There you go. Final answer. Done. Does that make more sense, Sebastian?
Yeah.
Yeah, it sounded like you were getting it. Good. All right. Cool. Let's go ahead and do the last one. Number 8. All right, number 8, let me call on Bowen. All right, Bowen, try this one out.
So you're gonna do the positive and or negative first. So first one is negative,
All right, negative. Good.
and then negative,
Good.
negative, and then negative.
All right, so how many sign changes do you see there, Bowen?
No.
Good. None. So that tells me what? I have no what?
Positive.
Good. I have no positives. Good. All right, let's go to the next one. What do I do?
Find a negative.
Good. All right, so if I plug in negative x for this one, do I get positives or negatives?
Positive.
Okay, x to the 4th would be positive, but times -2 would be
Negative.
negative. Okay, what about this one?
Positive.
Good. What about this one?
Negative.
Okay, but if you do -2 times negative x,
Oh, it's positive. Positive.
positive. Okay, and this one is?
Positive. Oh, there's no x, so negative.
No x. Okay, I was like, All right, so Bowen, how many sign changes do you see?
2.
Good. 1, 2. So that means I can have 2 exactly, or?
Yes. Or 0.
0. Good. All right, so 2 or 0 negatives. All right, so let's build the sign, Bowen, or build the chart. So how many positives might I have?
2.
Whoa, positives.
Oh, zeros.
0. How many negatives might I have?
4.
What?
2 or 0.
Okay, so pick one of them.
2.
Okay. How many should I expect in total?
2.
Look at the highest exponent.
4.
Okay, so I have 4 total. How many imaginary numbers must I have? I need to have 4 total. I have 0 positives. I have 2 negatives. So I need to have how many?
2.
Okay. All right. Or what else could happen? I can have 0 positives, or
So
I did this one already. I have 0 positives, 2 negatives, or I can have 0 positives and
0 negative.
0 negatives. So how many imaginaries must I have?
4.
Must have 4 to get that total. Good. All right. Final answer. Okay. Good job, Bowen. Nice. Okay. Questions.